Hi, this is Andrea Hendricks, and the topic of this video is how to solve quadratic equations by factoring. First, let's review what a quadratic equation is. It is an equation form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a can't be 0. If a was 0, the square term would go out and it would be a linear equation, not a quadratic equation. So a quadratic equation is an equation whose highest power on the variable is 2. This form, ax squared plus bx plus c equals 0, is referred to as the standard form of a quadratic equation. The property that will allow us to solve these types of equations is called the zero factor property. It states that if a and b are real numbers, and if a times b is 0, then either a is equal to 0 or b is equal to 0. Because let's think about it. What do we have to multiply together to get 0, right? 3 times what gives me 0? Well, 0. What times 6 gives me 0? Well, it has to be 0. So if we know that we have a product of two things equaling 0, one of those factors has to be 0. So how does that extend to solving quadratic equations? So what we'll do is write the equation in standard form, that is, make one side of the equation 0, factor the polynomial. If necessary, it may already be in factored form, but if it's not, you have to factor using the skills you've already learned, and then set each factor equal to 0 and solve. For quadratic equations, you should always have two solutions. That does count repetition, so if one solution repeats, then that's considered two solutions. So here's an example to solve the equation. If we think about our steps that we just reviewed, we have to have one side of the equation equal to 0, which we do, and then the other side has to be factored. Well, notice that x plus 5 times x minus 3 is already factored. We don't want to undo that multiplication because we already have it in the form of something factored equals to 0. So if x plus 5 times x minus 3 equals 0, this tells us that either x plus 5 has to be 0, or x minus 3 has to be 0. We can solve these linear equations by subtracting 5 from both sides to get x is equal to negative 5, or we add 3 to get x is equal to positive 3. So our solution set includes the numbers negative 5 and 3. 2x times x minus 7 is equal to 0. This is the same setup. We already have something multiplied together is equal to 0, so don't undo the multiplication. Notice that 2x is a factor, so we set that equal to 0, or the other factor is x minus 7. So if 2x is equal to 0, remember that's multiplication, so we have to divide both sides by 2 to get either x is 0, or we can add 7 to both sides to get x is 7. So our two solutions are 0 and 7. Now you can check, right? We can plug in the 0 for x or the 7 for x and check that everything works out. Okay, here's one we're going to have to do a little bit more too. It's y squared plus 3y minus 4 is equal to 0. Well, the equation is already in standard form, so what we need to do now is try to factor this trinomial, y squared plus 3y minus 4. And this is a nice one in that the coefficient of y squared is 1, so it suffices to look at, first of all, y squared factors as y and y. What are the factors of 4, whose difference is 3? And that would be 4 and 1. If there's a difference on the last sign, the signs in the binomials have to be different, with the larger one being positive. So we have it as y plus 4 times y minus 1. Factoring is key here. If you get your signs wrong, obviously the solutions are going to be incorrect. So we'd have y plus 4 is equal to 0, or y minus 1 is equal to 0. So if we subtract 4 from both sides, we get y is equal to negative 4. We add 1 to get y is equal to 1. So negative 4 and 1 is our solution set. For x squared is equal to 24, minus 5x. We have to do a lot of work to this one. One side is not equal to 0, so we need to put it in standard form first. So to put it in standard form, we can add 5x to both sides to get x squared plus 5x, and then subtract 24 is equal to 0. Now we factor x squared plus 5x minus 24 by finding the factors of 24 whose difference is 5. And if you don't know that, you can list the factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The one whose difference is 5 is 3 and 8. With the difference on the end, these signs have to be different, with the larger one being positive. So we put a plus on the 8 and a minus on the 3. So now we can set each factor to 0. So we get either x is equal to 3 or x is equal to negative 8. Okay. Now, just to check, maybe just to clear your mind here that this process does work, let's plug in 3 for x. So if we did 3 squared, is that equal to 24 minus 5 times 3? 3 squared is 9, and this is 24 minus 15, which is 9, so that checks. And the same thing would be true if we plugged in the negative 8. Now another one, we have 12p squared is equal to 8 minus 10p. So we would have to say 12p squared plus 10p minus 8 is equal to 0. This one's a little bit more involved because we have to look at the factors of the 12 and the 8. Remember the AC method says 12 times 8 is equal to 96, and we need to find the factors of 96 whose difference is 10. Okay? And so if we look at all the factors of 96, let's think about what those are. We have 1 in 96, 2 in 48, 3 in 32, 4 in 24, 6 and 16. And we can go ahead and stop there because 6 and 16 have a difference of 10. So remember how to put this in. 12p squared, we need a plus 10p, so we need to put in a plus 16p minus 6p minus 8 is equal to 0. And then factor by grouping. So between 12p squared and 16p, we have a 4p in common, which leaves a 3p plus 4. Between negative 6p and negative 8, we have a negative 2, and that leaves a 3p plus 4 is equal to 0. So we get it as 3p plus 4 times 4p minus 2 is equal to 0. So now we can set those factors equal to 0 and solve. So we would subtract 4 to get 3p is equal to negative 4. So p is negative 4 thirds. Or if we add 2, we get 4p is equal to 2, and dividing by 4 gives us p is equal to 2 fourths, or that reduces to 1/2. So our solution set consists of negative 4 thirds and 1/2. Okay? So again, the key to all this is factoring. What about x squared is equal to 64x? Putting it in standard form, we get x squared minus 64x is equal to 0. X squared minus 64x has an x in common. If we factor out an x, that leaves x minus 64. So if we set each of those to 0, we get either x is equal to 0 or x minus 64 is equal to 0. Well, x is equal to 0 is already solved. If we add 64, we get x is equal to 64. So the solution set there is 0, 64. I wanted to compare these two problems because they're very similar and easy to get confused. The next one is x squared equals 64, so if we write that in standard form, we get x squared minus 64 is equal to 0. But x squared minus 64 is the difference of two squares. So that factors as x minus 8 times x plus 8 is equal to 0. So notice the difference when there's a variable connected to the 64 and when there's not. So we would set those to 0 to get x minus 8 equals 0 or x plus 8 equals 0. So our solutions are either 8 or -8. Okay. What about r times r minus 5 equals -6? This is a case where we have a product on the left. It's already factored, but it's not equal to 0. So this product doesn't do us any good. So we have to undo that by squaring or distributing to get r squared minus 5r is equal to -6. Now we can put it in standard form by adding the 6. Then we have to factor r squared minus 5r plus 6. So we ask ourselves, what are the factors of 6 whose sum is 5? And that would be 3 and 2. With the sum being on the end, these signs are the same and they're both negative. So we get r minus 3 is equal to 0, or r minus 2 is equal to 0. So our solutions are r is equal to 3 or r is equal to 2. Okay. The last problem, 3x times 2x plus 7 equals 12. Again, we have a product, but it's not equal to 0, so we have to undo that multiplication. 3x times 2x is 6x squared. 3x times 7 is 21x, and that's equal to 12. So we have 6x squared plus 21x minus 12 is equal to 0. Now, if you notice, there is a 3 common to everything, so if you divide by the 3, you can only divide by a numerical value, not a variable. But if we divide by 3, we could reduce this to 2x squared plus 7x minus 4 is equal to 0, which may be a little bit easier to factor, because now we're looking at 2 times 4, which is 8. And what are the factors of 8 whose difference is 7? And that is 1 and 8. So if we put in these factors, 2x squared, between 8 and 1 to get a positive 7, I need a plus 8x minus a 1x, and then minus 4 is equal to 0. So 2x squared and 8x have a 2x in common. That leaves an x plus 4. A negative x minus 4 have a negative 1 in common, which leave an x plus 4, right? Because when we divide by negative 1, it changes the signs. So the factored form of this is x plus 4 times 2x minus 1 is equal to 0. So we set the factors equal to 0, and we get that either x is equal to negative 4, or if we add 1, 2x equals 1, so x is 1/2. So our solutions are negative 4 and 1/2. So if you have any questions on this, please contact me. Thank you.